Today's topic will be covering on reality mapping and integrated workflow. Get an insider's guide on the reality mapping workflow from flight planning and image capture to creating 2D and 3D maps and using the essential tools that power smarter decision making. Today's presenters, Lord Kit Yang, consultant in Esri, Malaysia. Without any further ado, I shall pass this presentation to Kit.
Thanks for the introduction. Hello, everyone. Today, my topic is talk about reality mapping and integrated workflow. Imagery in the past decade and more prove that are a needful layer of information in a modern GIS system and more so far Intel application. In recent years, the variety of sensors that produce data in the form of a raster has become some numerous and so different that they often require different software to be managed. But once transformed, they are always end up having the same use. They are used as an information layer which together with other or individually contribute to understanding and taking an action. To take full advantage of this variety of data, a comprehensive imagery system is available that once solve the particularity of the data convey the plus in a unique system. This is what ArcGIS does. It supports all aspects of the imagery life cycle from image capture through to visualization. In a bit more detail, ArcGIS allows us to create GIS-ready product with the reality suite. We can then manage, organize, and share imagery with our imagery serving suite. You can then visualize the imagery with your existing data on mobile, desktop, and the web platform in 3D, 2D, and even through time. Finally, Esri has a lot of imagery content. So in addition to your data, the ArcGIS Living Atlas provide image-based map and catalog of past and present imagery, such as the Landsat series. A number of content provide also supply imagery in ArcGIS ready-to-use format as download or web service. As my today's topic is about ArcGIS reality, let's begin by considering what is reality mapping. We describe reality mapping as the process of creating accurate digital representation of the physical world using image, LiDAR, or both. Reality mapping is about bringing reality capture and GIS together with a focus on geospatial accuracy. Reality mapping in ArcGIS allow you to create or update foundational content through highly automated processing. Using imagery from drone, airplane, or satellite, you can create 2D products such as True Auto, multispectral auto mosaic, thermal, elevation model. Video can become geospatial data product when associated with the right orientation data. 3D product like point cloud or mesh has become an essential part of what helps us understand our world. This content is highly accurate down to the pixel and is analysis ready for workflows such as feature extraction and change detection. The 3D data product allow you to build a photorealistic GIS experience which can serve as the foundation for the creation of digital twins. Reality mapping empowers GIS professionals to create an intuitive 3D GIS that non-specialists can actually easily relate to, enabling engage with geospatial data in real-world context. We enable reality mapping through ArcGIS Reality, a software suite designed to serve the diverse needs of users. ArcGIS Reality supports a variety of input, imagery capture from drone through aerial aircraft or satellite using RGB sensor, as well as thermal, multispectral, and soon LiDAR. It processes this data to generate 2D data products such as True Auto and digital elevation model, as well as 3D mesh and 3D point cloud. You can also manage set of individual still image or video in a geospatial context through oriented imagery catalog. All these data products then seamlessly fit into GIS and BIM to perform a variety of analysis tasks from inspection to feature extraction. So how does ArcGIS Reality work? The ArcGIS Reality processing workflow begins with the input data, importing overlapping image with location and orientation information. Optionally, you can also import result from third-party area triangulation. But if you aren't using a third-party AT solution, the second step is to perform alignment to refine orientation of imagery. This is referred to area triangulation or bundle block adjustment. The last step is to producing output product through reconstruction. Now let's take a closer look at the output you get from ArcGIS Reality. First, ArcGIS Reality let you create accurate 2.5D digital elevation model. This can be used for topography survey and hydrologic analysis. Second, there are True Auto, which provide a pixel accurate imagery layer. This means each pixel in the image is partially consistent with mapping data and elevation. And True Auto are also consistent between multiple flights. You can use them to perform a precise measurement and apply change detection and deep learning algorithm. And in 3D, you can create point cloud to provide highly accurate representation of reality. They can be used for precise 3D point measurement and point cloud classification. And you can also generate a mesh as photorealistic carrier format for your geodata. It's an intuitive way to empower non-specialists to interact with your data. And it let you integrate your existing metadata. You can generate fully 3D mesh for site and citywide mapping, as well as 2.5D mesh, which is suited for countrywide mapping. So after you have fly your drone to capture data, you can start to use our ArcGIS Reality for ArcGIS Pro to actually process your data. To start, you can go to the Imagery tab and select New Workspace. Provide name for the new workspace and select Reality Mapping for the workspace type. Select Drone for the sensor data type and select Drone for the scenario type. And for base map, I will follow the default option. And you can also select the base map to suit your project, as Esri provide a variety of base map options for you to choose from, and the other two options. I will follow default as well, then I click next. Follow the default option for sensor type also, then click add and select the drone image folder to load all drone image for process and follow default option for the geolocation, spatial reference, and camera parameter, then I will click next. Follow default option for the elevation source, and I will check for the calculate statistic and also view pyramid. And click finish to run the process. And once finished build the image collection, I will start the block adjustment process. Click at the adjust tool. Same, follow default for the perform camera calibration option. Then I will expand the advanced option. And this for my project, I will actually uncheck the use orientation from metadata. And at the type point matching, for the mask polygon feature, I will select the project boundary and I will click run to start the adjustment. So our reality mapping tool provide the option for user to actually import GCPs to enhance the accuracy of the block adjustment. You can import the GCP file by looking back to your project and click on the GCP file, and also set the GCP spatial reference. Then click OK to import the GCP file. After you have done with the adjustment process, you will start to generate the 2D and 3D product by click at the multiple product there. Then I will choose to select all the 2D and 3D product. Then I will click next. Follow the default option for all the output setting. Then I will click finish to generate the product. And this is the output for True Auto, DSM, and also 3D mesh, and also the point cloud. So after you have prepared the imagery, right, you can actually transform it into actionable insight through GeoAI and or advanced image analysis. Quickly uncover insight from imagery at scale with advanced image analysis, including feature extraction through geospatial artificial intelligence, which we call it as GeoAI. Change detection and time series analysis. Conduct analysis on various data types such as auto imagery, motion imagery, LiDAR, and radar. ArcGIS integrates spatial analysis, image analysis, 3D analysis, and artificial intelligence, which is AI, into a robust system capable of managing large datasets across both local and global scale. It combines imagery from street level, drone, aircraft, and satellite sensor with spatial data, supporting both basic and advanced workflow to generate comprehensive insight that drive informed decision making. You can leverage ArcGIS pre-trained deep learning model and spatial machine learning tools supported by spatial experts. Our pre-trained model enable anyone to begin extracting, classifying, detecting, and solving problems with your existing data. No need for custom training data. Additionally, our machine learning tools provide intuitive UI-based options with data-driven default to help guide your analysis. You can also adjust ArcGIS deep learning model and machine learning algorithm to meet your specific parameter and accuracy goal. We offer the flexibility to access advanced settings and make customization as needed. We offer pre-trained model across various industry and application to address challenges and proactively seize opportunity. This includes optimizing probe yard, enhancing community safety, streamlining access inspection, reducing emergency response time, and much more. But what if you don't have what you are looking for? You can absolutely bring this deep learning workflow together to create your own model. With ArcGIS pre-trained model, you basically get rid of that labeling and data prep phases. So you don't have to spend much more time because that labeling, preparing the data, and training the model is very time intensive. And that's where the heavy lift comes in when building this model. And all of this can be streamlined using geoprocessing tools. You can automate it with Python and then even scale this out into your online and enterprise environment. I can even share it directly from Pro into my online organization so that other can work with the same work with the data as well. So Esri to provide user the pre-trained model for user to use to run the feature extraction. You can go to the ArcGIS Living Atlas and insert DLPK, which we call it as a deep learning package, and click search. Then you can see those are the deep learning package that Esri are prepared for user to use. You can see we have a building extraction, tree extraction from point cloud or imagery. Also root extraction. And many more. You can just click download to download the DLPK file. And this DLPK file can use it in our ArcGIS Pro application. In ArcGIS Pro, I go to the job processing pane and search for detect object using deep learning tools. So I will insert the true auto output as the input raster. Then I will give a name for the output detected object. And I will select the DLPK that I have downloaded from ArcGIS Living Atlas for the model definition. Then I will click run. And here is the output for solar panel, parking lot, and also tree. For solar panel, right, I can actually add in field for like install date, watt hour, and also date last inspected. And all this information is used for the maintenance department to keep track of the solar panel maintenance. And once all these jobs are done, we can actually share this output as a web map for our maintenance team to perform their maintenance job. Visualizing this data is critical for contextualizing imagery analysis and putting it into action. ArcGIS visualization capability enables scientists and analysts to transform complex imagery and GIS dataset into understandable and tangible solution. From using data to visualizing it, to achieving insightful understanding, user can extract maximum value from their imagery data at every step. For decision maker and the public, visualization convert analysis into a narrative that uncover and communicate the story within the data. Esri provide imagery and GIS tool for data-driven application for geospatial analysis, as well as knowledge-driven solution, including ArcGIS Dashboard, ArcGIS Experience Builder, and ArcGIS Story Map. For public understanding and decision making, ArcGIS adaptly scale collaboration, visualization, and transparency for a wide range of users. Seamless integration and a wide variety of tools ensure that whether the goal is to inform policy, guide business strategy, manage resources, or engage the community, imagery tells a story that is both robust and accessible, giving a panoramic view of our world. So here is the web map that I share from my ArcGIS Pro. And in this web map, in addition to the True Auto, I also upload the drone image that I captured earlier. And because our imagery do have the date info, right? Therefore, we can actually enable this time slider to check the construction progress, to see if the progress to actually follow our proposed deadline. And we also did share the feature that Actually, we extract using Esri GeoAI just now. I can also develop the experience builder from this web map by clicking the create apps. Then I can start to create the experience builder using this web map. The experience builder app that I developed. In this experience builder, I insert the 2D map and 3D scene for my organization to view. And in the editor, I configure two filters, where one is to filter to show those underperforming solar panel, and also to show up those features that require inspection. And this info is actually useful for maintenance team so that they know where is the solar panel that require maintenance. Other team member can also use this web map to run for object detection to perform car detection, as we're able to run object detection from ArcGIS Online and ArcGIS Enterprise. And that's all from me. And if you would like to find out more about our ArcGIS Reality, here with the resources for your reference. And you can also talk to us to find out more about our ArcGIS Reality.
Okay, so let's take a look at the question we have for now. So we got a question from Anna. Will ArcGIS Reality for ArcGIS Pro work with Pro 3.0 and earlier?
The answer is no. ArcGIS Reality for ArcGIS Pro is actually compatible with Pro 3.1 and later.
Okay, so thanks Kit for the answer. So we got another question from Darwin. Can I convert a satellite or aerial scan auto mapping workspace to a reality mapping workspace?
Thanks, Irene, for the question. The answer is no. In ArcGIS Pro 3.1, only conventional drone and area digital auto mapping workspace type can be converted to reality mapping workspace to create reality product.
Okay, so thank you for the answer, Kit. Okay, so I think we have a last question from Robert. I have a digital aerial auto mapping project that I would like to convert to a reality mapping project. Will my previously created auto mapping products be carried over during the conversion process? So maybe Kit, you have an answer for this.
Yeah, thanks, Ariel. The answer is no. Reality mapping and auto mapping use different underlying methodologies to generate product and manage the associate meta information. Reality mapping and the auto mapping product are not synonyms. Both type of product have unique characteristics to support their mapping and customer requirement. And because of this, each suite of product need to be generated from their specific reality mapping or auto mapping workspace. I hope I answer your question.
Okay, so thanks Kit for the answer. So that's all the time we have today. So if you have not answered your question, so we will surely reach out to you with the response. Okay, so I guess that is all the question that we can answer for now. Okay, so thanks Kit and thanks everyone for joining us, and we will see you for the next Direction Left online webinar series.